So now we're going to look at the variability of a symmetrical distribution of data. Now that we learned the basics of variability and deviations, we want to learn more about what it can tell us and better ways to use it. Now remember how we learned that the mean is the best way to represent a symmetrical set of data? Well, the best deviation to find in a symmetrical set of data is known as the standard deviation. So if we remember from the last video, brand A of batteries, its mean was 101 minutes of battery life. What we found from our data before was that a common deviation, or like the average deviation, was about 10 from this. 110, 91, right around here. So it's usually counting, it counts for a good amount of the points. Now we're just guessing that that's the most common deviation, but there's an actual way to calculate the specific common deviation, and that's known as the standard deviation. Now remember, when we're finding the standard deviation, it's just the more accurate way to find the variability of a data set. Now, the first step in finding the standard deviation is to find the deviation from the mean of every single point. Now we already did that before, if you can check back in the last video to see how we did that. The second step is to square each deviation you have. The third step is to add up all your squared deviations. This is going to give us a total of 736. The fourth step is to take the number of points you have, which in this case we have 6, and subtract 1 from that number of points, which will give us 5. Then you're going to take your total from the squared deviations and divide that by 5, which is, as I said before, the number of points we have minus 1. That's going to give us 147.2. The last and final step is to take the square root of this number. Now, with this square root, you don't have to take the positive and the negative number because we're trying to see the deviation as you go left or right. Now, even though there is a minus sign here, it's really just telling us that this deviation is to the left of the mean, not that it's negative. So when we find the square root, we find that our standard deviation is 12.13. So yes, it is close to 10, which was our original guess of what the common deviation from the mean is, but this is much more accurate. That what we're going to find more often is that it's 12. So I'm just going to go over the steps again. We have find the deviation from the mean of each point, square each deviation, add up each square deviation, then you're going to take the number of points we have minus 1. You're going to divide your total by the number of points we have minus 1. Then you're going to take that answer, take the square root, and that's our standard deviation. Now, 2 things to remember. The reason why I did 12.13 is because the best way to round the standard deviation is to the 100th place. What we need to know is that standard deviation is written as like this, with s and then a little x. So there's got to be an easier way to remember this. So what we're going to do is we're going to synthesize all the steps into one equation. So we're going to create our equation here, and it equals s of x. Now our first step, if you remember, is to find the deviations from the mean. So that's the mean minus the data point. The next thing we have to do is we have to square each data point. But we know that in the third step, we're going to need to add up all our squared data points. So how would you write to do this part a bunch of times and then to add them all up? What you use is a sign called a sigma. And what the sigma basically means is the sum of. So what you're going to do is you're going to take each point, as we said the 6 before, and you're going to do the square of each one. And what this tells us is to do every deviation from the mean, square every deviation from the mean, and then add every single deviation from the mean up. So what you can do is you can take this section, you can go up to the side and do that separately. The next step is to divide our total, which is the added up square deviations of the mean, and you're going to divide by the total number of points minus 1. So we're going to call the total number of points n, and we're going to subtract 1. And then once you get that, you're going to find the square root. So we're just going to find the square root of that. This would be our equation. So let's see if it works out. So let me just explain this equation one more time. Basically what this is first step, find the deviation from the mean and square it. Do that for every single point and then add them up. Then you're going to divide that total by the number of points you have, minus 1. And then once you have that, you're going to take the square root. And that's going to be your standard deviation. And remember, it's to the 100th place. Like our deviations before, our standard deviation, if it's bigger, it means that there's going to be more variability. If it's smaller, there's going to be less variability. So let's look at two symmetrical dot plots. Here we have one that looks like a mound, and here we have one that is uniform, which basically means the same amount of points, same amount of dots for each value. The question is, which one is going to have more variability? The mound is going to have less variability because most of the points are concentrated around the mean or around the average. And the mode are around 1 point. Here, the mode is for every single point. So if we look at this just like we looked at the batteries in the previous video, this battery type is more likely to be one value. And here, the batteries are more likely to be multiple types of values than just one value. So to sum that up, a mound-shaped distribution is going to have less variability than a uniform point distribution. Now, I just want to add a quick note. Now, if your dot plot only has points on one value, you aren't going to have a deviation because you don't have points that are different from the mean. Your mean is always going to be that one value. So in that case, there is no deviation, there is no standard deviation. So to sum up, the deviation and the standard deviation are telling us the variability of our set of data. Hey, thanks for watching this crash course video. To watch the previous video in this series, click here. To watch the next video in this series, click there. If you want to request a video, make sure you put it in the comments below. And don't forget to subscribe and like this video.